The product of three positive integers, x, y, and z, is 64. If x is greater than y is greater than z, or sorry, backward. If x is less than y is less than z, which basically just means that they're distinct integers. These are three different factors. Then in how many ways can the numbers be chosen? So how many ways can we create three positive integers as factors? The factors cannot be 0. The smallest one has to be 1. So I'm going to try and work from my smallest factors upward progressively in an organized fashion. Hopefully I'll catch all the possible arrangements. So if I had 1, the next one can't be 1 again. It's got to be a different factor. 2, the next higher one. And then I know that last one has to be 32 to equal 64. Okay? So that's one option that works for us. Let's keep going with my 1s up front. 1... Well, 2, I could go up to, well, the next one would be 4 for my next factor higher. And that would be multiplied by 16. That does give me 64 as well. So that works. Next, going up, I probably go 1, 8, 8. Uh-oh, the 8s are the same. That does not work. I can't do that. And if I went up to 1, 16, and so on again, then I already captured that. I have 1, 4, 16. So I really don't need to go further with my 1s. I can now start with, say, the next higher possible factor, 2. Well, what could I do? I could do 2 times 2. Well, I can't do 2 because that's the same integer. So that one's not going to work. Let's undo that. I would have to progress upward. 2 times 4... which gives me 8, and then 8. That will work as well. 2, 4, and 8 equals 64, and they are distinct factors. Okay, well, what else could I do? Then I could go up to 2 and 8, and no, then I'd have to go down to 4, which is basically the same thing. So it looks like I'm done. I could step up to 3 is not a factor of 64. I could step up to 4, but again, that's not going to work, because once I'm at 4, I would have to go with something like 16 and 1 or 8 and 2. And I've already captured all of these up above, so none of those work. I'm essentially done. I've finished. There are 3 different combinations of x, y, and z that meet the conditions of the question.